Okay,
Good
that's
luck.
great. Great, thank you. All right, and thanks, Danny. That was a good presentation. I only caught the end of it because I was busy fighting my kids, trying to get them ready for school, but I'm here now. Right. So we're going to start off with a question or kind of problem which you may have been asked to solve at work, and that is you've been asked to get the first 3 hires in each department. Basically, this is a top N per group type problem. And there is no native SQL syntax to do this in SQL. You've actually got to kind of build it up. We do have the fetch first syntax to get just the first N rows, but if we want the first N in a particular group, in every group, we need to go through a number of stages. So there's some ways you can tackle this, and one way is like this. First up, we're going to assign a row number to each employee per department, so sorting by hire date. So partition by department ID, split them up by that, sort them by hire date, and assign row numbers 1, 2, 3, 4, and so on and so forth. We'll do that in a subquery, and then we'll filter it down to the top N of those in an outer query. So we can solve the problem doing like this. So you might have been asked this, but chances are you've actually been asked something similar to this, not quite the same. For example, maybe you want to get the last 3 orders for each customer. Again, what we're looking for here is the top N per group. So if we look at the query I just wrote, all we need to do here is actually change the column and table names in it. If I just swap those out for orders, customer, order dates, and so on, then actually the structure of the query is basically the same. We're just passing in different columns and table names. So we've kind of got this template for a query. And at this point, some wise person is probably sitting there thinking about this and going, well, wouldn't it be really good if we could reuse this template and just create a function or something like that that we can pass the tables and column names to. So if you've been asked this by someone on your team and have to write in that query, chances are you're kind of feeling a bit despondent and kind of going, well, no, not really. We can't really do this in SQL. Why not? Well, if we try and do something like this and try and bind in the table names, I think most people, after learning about bind variables, try and attempt to do something like this. We go, say we want to pass in table and column names dynamically. So try and write a query like this. Problem is, you cannot bind identifiers, so table names, column names, that kind of thing. So this just doesn't work. And there are alternatives. Instead of doing like this, what we could do is use dynamic SQL, construct this string at runtime based on the parameters. So use a string concatenation to accept the table and column names and open a ref cursor to return the results. So this has a couple of problems. First up, what we're returning here is a ref cursor, which isn't quite the same as just running the plain query itself. You need to handle it slightly differently. So in particular, we can't then take a ref cursor and then join that to another query and things like that. But perhaps more importantly is that as soon as you're using string concatenation to construct SQL statements, you're at risk of SQL injection, right? So there is a very high chance of you getting it wrong when doing things like this. You have to take lots of steps to make sure that people aren't passing in dodgy strings, things like, where 1 equals 1 and things like that, so they can see all the rows or see stuff that they shouldn't be able to. So it's really easy to make a mistake here. So, this question of can we make this a reusable statement kind of strikes at the heart at a common criticism of SQL, which does have some validity. That is that it lacks this kind of composability, the ability to define smaller units that you can build up into larger SQL statements. Like I say, we do have it to some degree, but it is quite limited and quite hard to do. Or at least it was. With the things have now changed with the advent of Sql Macros. So with these, we can then actually create functions which we can pass table names and column names to make reusable SQL statements. I'll see how we can do that in this session. So hi everyone, I'm Chris Saxon. I'm part of Gerald Denzel's developer advocate team and part of the answer team on Ask Tom. It's my job to help you get the best out of Oracle database and hopefully have some fun while whilst doing so. So with that in mind, as I said, today we're going to be looking at SQL macros and how we can use these to make really maintainable SQL and kind of solve this problem we've just been talking about a bit. Before we get into kind of the details of macros, just a few kind of little overview details. First up, SQL macros come in two flavors, table and scalar. So the difference in these is where you use them in your SQL statement. So table macros, as the name probably implies, replaces an actual real table. So you'd use these in the from clause. So that would be instead of a real table, a view, name subquery, and that kind of thing. Scalar macros essentially replace PL SQL functions everywhere else. So you can use them in your select clause, your where clause, your order by, and so on and so forth. Pretty much everywhere else, it's legal to use a PL SQL function, right? So that's kind of high level difference between those two. So they're not kind of fully compatible. Second thing to note is SQL macros was originally slated to be a 21C feature. However, table macros have been backported to 19C. Scalar macros are still 21C only. I do have to do a little asterisk at this point and say autonomous is off on its own little kind of version train by itself. If you're using Oracle Autonomous Database, SQL macros have been fully backported to 19C there. But for other offerings, so Database Cloud Service, Enterprise Edition, Standard Edition on premises, SQL macros, Scalar macros are still only in 21C. So good news is if you're patched and up to date on 19C, you've already got table macros. If you want to check out Scalar macros, then you'll have to look at 21C. Good news there is XE was just released a couple of weeks ago for Windows, and it's been out a month or so for Linux. So that's kind of high level. We've got these two kind of macros, table and scalar. Next thing to know is when you create a macro, what you're actually doing is returning a string. So we've now got this new clause, SQL macro, which we use to define which one it is, so table or scalar. So this is optional to state which it is. If you omit the type, then by default, they are table macros. And you'll notice here, I am returning a clob. That's because SQL macros return text. They return character data, a string. And this is the expression you are returning, which is going to become part of the final SQL statement. So essentially, the database takes that and kind of pastes it into the final SQL statement. So I've got lots of examples of how that works so we can see what's actually going on in detail. Final is kind of a small detail, but useful to know. SQL macros are implicitly deterministic. So that means given the same input, we have to return that same string as an output. You cannot, however, specify this deterministic clause. If you try and add it, you'll get an error. So they are implicitly deterministic. So that means you can't have things which will change the output at runtime based on things like something like sysdate, if you're going to change the string you're returning based on sysdate, or you're running a SQL query inside your macro, which is going to affect the expression you return. Those can be non-deterministic, and so you can't do them in a SQL macro. Well, to be strictly true, you can do them. You won't get an error, but unexpected and weird things will happen if you try and do it. So important to be aware of that. Make sure you make them deterministic. So that's the overview. Let's start talking about table macros. And using these, we can make our reusable top n per group function. Before we do that, I'll start off with something a little bit simpler. And we'll just create a generic top n function, just return any n rows from a table. So as I was saying, you can do this from 12C with the fetch first syntax. So we can say from a table, get this number of rows. So this is the template query, the expression we're going to return in the macro. So I want to return that as a string. So I need to quote it. Then I'll create the function, which has the parameters table, tab, and the number of rows. And that's returning a SQL macro. So I haven't said what type, so it is a table macro. So how does this actually work? How does the database figure out what's going on here? Well, essentially what happens is at parse time, the database does a find and replace of those parameters in the string and replaces the actual text of the values you pass for those parameters. So it searches for those parameter placeholders in the string and looks at what you've actually passed, and I say textual replacement. So looking for that and replacing that in the string. So for example, if I call this function top n with employees table and get 3 rows, the final Sql statement actually looks something like this. We swap in the table name and 3 rows we're getting from this. So pretty neat, right? Now, of course, in a real application, we shouldn't really be hard coding how many rows we're getting. We should be using a bind variable there, so we can change how many rows we're getting each time we call this, right? So what happens if we change the table, we're getting from the orders table n rows, bind variable rows. Well, as I say, the database does not peek at that bind variable. It doesn't look at its value in any way when resolving the macro. Literally, that bind variable itself becomes part of the final Sql statement. So what we get at the end is from the orders table, we're getting bind variable rows only. So calling this function is equivalent to running that query below. So that's bind variables, but what if we want to pass a function, for example, instead? We're defining how many rows we want to get in terms of that. So we've got our getN function. Well, again, the database, when resolving the macro, it does not execute the function. It doesn't get the value out of it and make that part of it. Literally, the function name itself becomes part of the final Sql statement. So what we actually have is from the sales table, we are going to get the n rows only. And we can actually pass in any expression which is legal to use in that clause. So we could even pass in a subquery as well, should we wish to do so. And literally the subquery becomes part of the Sql statement. So that's if we're doing like a top n. We wanted to make our top n per group function. So start off with, we'll create it, and we need to accept the table, which columns we're grouping and ordering by, and how many rows we want. So we're going to have our different tables and columns there. And then we've got our template query like this. So if you remember at the start, I had my query to get the first 3 hires in each department and so on. Essentially, that is the template, and I'm using that in the Sql macro. So that is the string we are returning. And we can see we've got the table, the number of rows, group, and the ordering columns. Now, at this point, you might be wondering why I've kind of like qualified those columns. Well, the database will automatically substitute in the table name and the number of rows, whatever we passed for those, but it will not automatically substitute in the columns. So why is this? Well, to answer that, we need to look in a little bit of detail the difference between the types of parameters that we can pass. So table macros introduce, or Sql macros in general, I should say, introduce 2 new parameter types. And they are a column table T and columns T, and these are in the DBMS TF package. I say new, I mean, strictly speaking, they were actually new in 18C with polymorphic table functions, and we just kind of reused them a bit, right? But we've got these 2 parameter types. So table T, as the name kind of implies, it is a table that we are passing. And I say a table, it could be a view, because tables and views kind of are substitutable in Sql, or it could be a common table expression, name subquery with clause, whatever you want to call it. So any of those are legal for us to pass as a table type parameter. Key thing here is we can only pass one of those for each parameter. The columns T, however, accepts we use the column pseudo operator to pass a list of columns, a comma separated list of them. So we can actually pass any number of column names that we want, column identifiers. So what that means is table we pass one thing, columns we pass many things, or potentially many things. So as a result, because we've got a one-to-one mapping between table parameters and placeholders in the string, the database can auto-replace them. But there isn't like an implicit way in Sql to take a comma-separated list and turn it into a string. There are ways to do it, but it's not implicit functionality, right? So the database does not auto replace that. We need to do manually pass in, put in those column identifiers as part of the SQL statement we're executing. There is another tiny little difference between these, and it's kind of subtle and probably doesn't matter in most cases, but it probably could be worth knowing. And that is the table type parameters always have to refer to a real object. So it has to be a real table, has to be a real view, or a named subquery that is part of your SQL statement. If you try and pass an invalid table name, one that doesn't exist, or you've not got query permissions on, then the macro itself is not executed. You'll just get an error, and it will never execute the body of the macro itself. With the columns type, on the other hand, you can pass in whatever you want, as long as they're legal identifiers. So, they follow the identifier rules in Oracle database. You can pass in anything there, and the macro itself will actually execute. Now, as I say, this is a kind of technical difference, because in most cases, you're going to use all those values from the columns operator. And if it's an invalid column, you're going to get an error when running it anyway. But it's possible that you could construct a macro where you don't use all the values that are passed for those columns, and it won't actually error if they're not part of the final SQL statement. So subtle thing, but could be useful, could be important to be aware of in some cases. So key thing here is tables are substituted automatically, columns aren't. So we actually need to do a bit more work in our macro. So in this case, what I'm going to do is just iterate through all those values. We've got an array of values, iterate through them, building up a string of the grouping and ordering columns. And then having done that, actually replace those at placeholders in the final SQL statement. So again, I had to do this myself manually. Macro did not do it for us. Table parameters are handled automatically. So having done that, we've got our top end per group function, and as I call this statement, it's identical to that first query we asked for. Get the first 3 employees in each department. What if I want change it to orders? So here I'm getting the first 3 orders for each customer, or first n orders. I'm using a bind variable here for each customer. Now, if you remember, you'd be like, hang on, didn't you ask for the last 3 orders for each customer? And I was like, that's true. If we want to change the ordering, we'll need to add in an extra parameter as a flag to say we're sorting ascending or descending for each column. I've got a demo a little bit later and show you how that actually works in practice. So pretty neat, right? We've now got our top n per group generically reusable function. Not only does this mean we can just pass anything we want to it, essentially, it's much easier to use, right? We just need to remember what the function name is rather than several chains of SQL. Because, I wouldn't necessarily say it's super hard SQL, top n per group, but it's certainly intermediate to advanced, and it's non-obvious if you're a beginner, right? With this top n per group, we can create this function. If you're a DBA database developer and you've got your front-end developers with little to no SQL skills, you can create this function for them and say, just call this, pass in the parameters that you want, and we're hunky-dory, right? So this is all great. But at this point, again, the wise person on your team is kind of looking at this and going, well, hang on. You said the reason we didn't want to use like dynamic SQL string concatenation originally was SQL injection. How does macros prevent SQL injection? Or what about SQL injection in these scenarios? Well, SQL macros are much safer against SQL injection. It's very hard to write a macro that is vulnerable to SQL injection. So first up, as I was saying, the database does the auto replacement of the actual values. But there is another reason which is important to be aware of as well. And that is if you accept character parameters, so varchar2, char, clob, that kind of thing. If you try and actually use their values within the macro, inspect their values, you can't. They are in fact null. So if we're trying to concatenate that string into the SQL statement, and someone passes in something like, where 1 equals 1 or union all, blah, 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 something else to kind of see things they really shouldn't be able to, that value is null and it never gets evaluated. It doesn't become part of the SQL statement. So we cannot inspect the values of character parameters within the macro. This, already is making us pretty safe. So at this point, we're going, well, what happened? What should we do here? We've got some character data we want to make part of the string. Well, you just put that placeholder in the string itself, in the macro that we are returning. And now, if somebody's passing something dodgy in there, like 1 equals 1 or whatever, it is returned as a literal, so a character literal. The database quotes it for you. Key thing here, it's not part of the SQL statement. It's not part of the SQL syntax. It is just a value that is returned by this. And again, I've got a demo showing you exactly what this means in practice. So the key thing here is it is difficult to write vulnerable SQL macros. I will say it's not impossible. I'm not going to tell you how, because I think leave that for an exercise for yourself. But it is very tricky. You kind of have to go out of your way to make vulnerable macros, whereas pretty much dynamic SQL by default it is vulnerable to SQL injection. So it is not only is this more reusable, but it is much safer to use macros as well. So that's kind of showing you how to create this table macro to make a top n per group function. And we can actually use this to apply to other types of SQL patterns or query patterns which don't have native syntax. So a few examples that I've walked through that crop up regularly for me is finding consecutive rows. So there's a couple of ways you can do this in Oracle database. There's something called the Tobibito-San approach or the match recognize clause. Again, they're kind of non-obvious. They're intermediate to advanced SQL, and they're kind of a bit of a pain to write. We can create a table macro which encapsulates all that logic for us. So that makes things much easier and much better to work with there. So finding consecutive rows. Another example is CSV, comma separated value strings, and turning those into a row for each individual value. Again, the query to do that is a bit gnarly in SQL. We can create a macro to do it. We just pass the string and get the results back. And another fairly common thing is date generation or just data generation generally. Other databases do have an inbuilt function for this. We don't really have that in Oracle database. You have to do lots of techniques you can use to do it. But with SQL macros, you can just create your macro to do it, and then it's just a function call with the relevant parameters. So those are common ones that I run into, and patterns which apply kind of universally. The chances are there's going to be some domain-specific ones that you can use as well. Maybe there's some common joins in your application, and you'd like to just encapsulate those in a macro so you can reuse them throughout your application nice and easily. Either way, key thing to here is whenever you've got like a query template that you would like to reuse, we can make a table macro for it. So let's move on and discuss a slightly different problem. Let's say you've been asked by someone in the business to do some reporting. They want to look at some analysis of expensive items. What expensive things have people been purchasing? And they want to find all the items which are more than 100 euros, right? And each time someone's purchased a particular product where the total value is greater than 100 euros. So in order to find that, chances are we have to do a calculation a bit like this. It's very common to store the quantity and unit price as separate columns. So we need to multiply those together to get the total. And of course, I said I wanted it specifically in euros. Good chance that, you as a business, you issue invoices in different currencies. To convert those into constant currency, we need to do an exchange rate conversion. So it's a fairly simple formula, but there are some traps and complexity to watch here. First thing to notice is what rounding rules are we using here? Different currencies have different numbers of decimal places for their minor units, right? 2 is the most common, but some have no minor unit, no decimal places. Some even have 3 decimal places for the minor unit. So which are we using there? How many decimal places of rounding are we going for? Secondly, a lot of businesses don't necessarily want to go for a straightforward rounding. It's 5 or lower, go down to the value below. Above that, go round up. They would like to go to the floor or the ceiling, whichever way is slightly better for them, right? So they gain like ½ cent on each currency conversion. It's a small enough amount that each individual consumer is not going to notice, but you do that across like a few million transactions, and you made yourself, a few thousand for free, basically. So you've got the rounding logic might have some specific rules about how you want to do it, and you want to be sure everyone's doing this in the same way. Secondly, and perhaps even more importantly, comes to this exchange rate conversion. How are we actually doing it? Are we multiplying or are we dividing? Okay, this is something I always have to think about very, very carefully and do lots of tests and check that we're doing it the right way round. And it kind of depends how we've represented that exchange rate. Is it the multiple or the reciprocal? All right. So key thing here is, although it's a relatively simple expression, there are some hidden traps. Also, it's likely to be reused throughout your application. Finding the total value in constant currency, that's a common operation. And we want to be sure it's handled in a consistent way. Financial data, everyone wants to be sure it's handled in exactly the same way, right? So we've got this common function with some complexity. We want to be sure it's handled in the same way. Someone kind of goes, well, can't we just make this a function? Can we wrap that logic in a function? You go, all right, then let's make that a PL SQL function. We'll stick the formula in there and use the function in our SQL statement. All good, right? We've made or wrapped all the logic, made it nice and reusable. Sounds great. Well, that is until we come to actually execute this query. And what happens? It's suddenly significantly slower than if we just had the expression in the where clause itself. It's like, oh, why is this? What's going on here? Well, the thing to remember is that SQL and PL SQL are separate runtime engines. Whenever you have a SQL statement that calls PL SQL, or vice versa, there is a context switch from one engine to the other, and then back again to return the result. So if we've got our PL SQL function in the where clause, we're essentially every single row we're processing, we're going to have to do that context switch. While those context switches are fast, you do that hundreds of thousands, millions of times, that effect stacks up and can really slow your statement down. So, this is quite often a lot of us learn this rules, like don't use PL SQL in SQL statements, or certainly not in the where clause. But something like this, an important critical functionality we want to be reused, what do we do here? Do we go for pure performance and say, make our application harder to maintain? Or do you say maintenance is king and accept the performance hit? There's not a simple answer here, right? And it can be something that you have to decide on a case-by-case basis, even if you prefer one approach over the other. Now, it is worth saying there are some actions that we can take to help avoid this. First up, we could create a function-based index. So what this does is essentially calculates the result of that function and stores it. So now we can actually look up those calculated results. So this can help in some scenarios, but not all of them, right? As Danny was talking about, full table scans and indexes, if the query is going to use a failed table scan, and that is the fastest method, the index doesn't help in any way here, right? So this is only going to help some queries, or those queries where we're fetching a small enough number of rows, we're actually going to use the index. Second thing to be aware of, not an issue in this case, but it is in the general case, the function has to be deterministic. Given the same inputs, we have to get the same outputs. And some functions, you're right, won't be deterministic. And if they're not, you can't create a function-based index. So this helps in some cases, but not all of them. So what else can we do? Well, in 12.1, we added this new pragma, user-defined function, UDF. And that essentially lowered the cost of the context switch, made it a bit faster. Didn't eliminate it entirely, but it did speed it up a bit. So this could help. So combined, we could help in some scenarios, not all. So let's say we've created our function, made it user-defined, call that in our Sql statement, and things are better, but not perfect, right? It's still slower than we'd really like it. So again, we're kind of still trapped in this dilemma. Do we go for maintenance or do we go for performance? Wasn't an easy answer. With Scalar Macros, we have a third way, a way out of this dilemma. We can get both of them, right? So how do we do this? So as I said, with a macro, we're returning a string. So we just change our function, make it return a varchar, declare it as a Sql macro that's returning a scalar, and just quote our formula. We can then use that in our Sql statement. And what that means is that the database resolves this at parse time. So at runtime, it's like the function doesn't exist. We're down to running pure SQL. So that means there is no context switch at runtime, eliminating that. This in itself is probably going to give you the performance gains that you need. You know, we got the maintenance of PL SQL, the performance of pure SQL. Fantastic. It is worth noting there is another little side benefit as well. PL SQL functions are essentially black boxes to the optimizer. It doesn't really know, at least by default, what's going on in there. By resolving this to pure SQL, the optimizer gets better visibility of the underlying expression, which means it's more likely to be able to find better plans. It's not guaranteed, and it's not going to help in all cases, but you've increased the odds, right? You've increased the chances of it finding the right execution plan rather than have used a PL SQL function. So seems like a winner, this, right? You know, we've got the maintain reusability of PL SQL. We've got the performance of pure SQL. So at this point, some of you might be wondering, why don't we just make all our functions macros? We've upgraded to 21C. Let's just convert every single PL SQL function to be a SQL macro. Or even you might think about this a bit further and go, why didn't we even just make this the default, right? Why don't we just do this under the covers behind the scenes so that this just happens for you? Well, there are a couple of important differences between PL SQL functions and SQL macros. First one is a little bit subtle, but is worth being aware of. And that comes to how it evaluates the argument, or how they evaluate the arguments. So let's create a little contrived example here, but we'll demonstrate the principle. So I'm just creating a wrapper for coalesce, return the first not null argument. So pass in those to that. So this is our PL SQL function. If I call this first not null, and I pass in 1 divided by 0 as the second argument, PL SQL uses application order for evaluating arguments. So essentially, it evaluates the expressions, then pushes them into the function. So it's going to evaluate 1 divided by 0. What's going to happen? We get a divide by 0 error, right? Okay, so that statement is going to fail. What happens if we create this as a SQL macro? We turn it into a scalar macro. So all we've done is change the return type and quoted the expression. If we now call this SQL macro, we change the argument evaluation. Rather than application order, we use normal order. Essentially, those arguments are pushed inside the function, inside coalesce. Coalesce returns the first not null argument and uses short circuiting. So the first argument essentially here to coalesce is 1. That is not null. It returns that. And it never evaluates 1 divided by 0. So we actually get a result here. Ooh, interesting. That is some quite different behavior. And like I say, this is a bit of a contrived example. But if you've ever got functions where you're passing functions to them as parameters, you could get a difference in behavior. Most of the time, it probably won't matter, but it will matter some of the time. So this is an important reason why we can't just swap them out to make them completely substitutable. However, there is a much bigger reason why we cannot just take your existing PL SQL functions and turn them into macros. And that is what happens if we call them in PL SQL. Well, As the name implies, they are SQL macros. So the substitution only happens in SQL. If we call them in PL SQL, what happens? You just get the text back, right? You just get the expression. You don't get the resolved expression at the end. Okay, so we can't use SQL macros in PL SQL, or at least not in the way that you would want to actually get the result that you're looking for. Okay, so very important reason why you're not going to be able to just make all your existing functions macros. So if you've got functions that you use both in SQL and PL SQL, you're going to have to think a bit, what do we want to do here? Maintain two versions of the function, create a SQL macro, and create a PL SQL wrapper around it, which just selects it from dual. Still a little bit of thinking and a bit of dilemmas for you to solve there. All right, so these are pretty neat though, and it allows you to create these reusable functions which get the performance of pure SQL. Now, one thing you might be wondering is, I've kept them pretty basic and simple here, but obviously the construction of these templates could get quite complicated. Wondering more, how do we resolve that? How do we figure out what's really going on here? How do we debug these? Well, a really useful way is this function expand SQL text, or procedure actually, which we added in 12C. And with this, you can pass it to a query and you get the final underlying statement. So the classic use case for this in the past would be if you've got a view. Quite often you've got a view to make some nice, simple SQL, and it can hide all sorts of complexity underneath. If you want to see that full complexity, you can pass that select star from the view into this and you get the full underlying thing. You can do the same with the SQL macro. Pass the macro to this, and you get the final resolved SQL statement. However, that resolution only applies to table macros, right? If you pass in scalar macros, you still just get the function in the statement itself, okay? So again, I'll show this in a demo, see what actually happens. So at this point, it's a great point to jump over to the demo and show you how this works. If you've got any questions or comments at this point, then feel free to just put them in the chat or the Q&A, and I can pick them up as we go along through this. So let's start off. Here's the problem we started with at the very beginning. Find the first 3 hires in each department. So we've got our inner row num query, and we're filtering by that in the outer query. So we can run that just to prove that does what I'm saying it does. We get up to 3 employees per department. So we can see 1, 2, 3. So let's create our top n per group function. So we want to simplify and make this reusable. So note, I was saying if you wanted to change the ordering, ascending and descending, you need to add a flag. So I've added an extra column here to say which columns we're going to sort descending. So that can be null. All right. So what I'm taking the approach slightly differently for constructing the string here, but essentially for each of these parameters, I'm iterating through them and producing a comma-separated list of the values. And if it's a member of the descending columns, adding the desk option to that as well. Actually, I probably need to add that. How do I? So we'll create that. And here is the final statement, and I'm concatenating in those column lists that I've just generated. So we'll create that. So now I can call my top n per group function with these values, and this is the same as that query I was running just a couple of seconds ago. You get the first 3 hires in each department. Pretty neat, right? We've simplified the SQL greatly. But even better, we can now pass in different tables and columns to this function. So let's say we could pass in different information. So as I say, we probably in a real world would want to use this as a bind variable. So let's do that. If I pass in, I'll pass in 1 to start. So we'll get the first employee in each department. You can see all these values are 1 here. We get 12. We increase it to 5. So the first 5 per department, or up to the first 5. You can see we get far more rows, and maximum of these is 5. So we can change that to use a bind variable. Again, we could use a function here. I'm just going to hard code 5. It's just a simple function to demonstrate the principle, and we can call that in here. And this time I'm getting the last 3 orders, or last n orders, so 5 in this case per each customer, and we can do top n per group. So there we go, we can get that information as well. So we see our row numbers here, up to 5 orders per customer, and they're sorted by the date descending. So it's pretty neat, pretty handy, and we can do all sorts of cool things. As I said, we have to pass in a real table or a real view, but if we want to pre-prepare the data in some way, you can also pass in a named subquery with clause common table expression. So I want to find who are the best customers in each store, who places the most orders, who are the best repeat customers. So in order to do that, in our subquery, we just group by customer and store and get how many they placed, and then we will find the top n per store sorted by the count descending. And again, I've used a bind variable there to do that. Say get the top 2 customers for each store. There we go, pretty neat. We've got the results and we made our generically reusable thing. I think this is brilliant. I'd love to know what you think about this. Okay, so that's like the example. Let's go on to the Sql injection. So let's say I've got some dodgy string here, and I'm concatenating it into the function that we actually create here. So if I create this, as I said, this value, when we inspect it in the function, is null. So you will never get its value. So if I try and pass in some dodgy unional Sql injection-y type thing and execute this, we're going to get an error. So why is that? Hopefully I'll run it like this. There we go. The final Sql statement we've got here is just select something, nothing from C. That whole dodgy string value has disappeared. It is null. We cannot inspect it. So if someone is doing something they shouldn't do, then they can't get in and see what they want. So let's do it right. Let's put it inside the actual string. Okay, so dodgy string is the placeholder in here, and if we create that, so what happens here if we call this? Well, as I say, this is now a literal. So actually, we will get just this text back for that column. Let's pass that in from Joule. See, we've just got that text. Key thing here is this has not become part of the Sql statement, right? We have not injected it in. We just selected that value. So as I say, it is very difficult to write vulnerable macros. Not impossible, but you kind of have to go out your way to do that. So that was the injection. Let's move on to Scalar Macros, and we'll start off by looking at that difference in behavior. So we'll start off with our PL/SQL function, just a wrapper for coalesce, pass in 1 divided by 0. And of course, we get an error. Dividers is equal to 0 because it evaluates this before passing it to coalesce. Let us now change this first not null to be a scalar macro. So all we've done, I've changed the return type here and quoted it. So let's just change that like that. So now we essentially push these values into here. So we're essentially coalescing 1 and then 1 divided by 0. Coalesce uses short circuiting. So when we execute it, hey, we actually get the result. Okay. So like I say, a subtle thing, but it is important to be aware of that you can get differences in behavior in some cases. Particularly if you've got passing functions which have side effects. So do something in there, like run some SQL, some DML, insert, update, delete, or do something else in the application. Be aware that in some cases they may behave differently. But back to probably the biggest and most important reason why you're not going to just make all your existing functions scalar macros. If we now call this in pure PL/SQL, we literally just get the text of the expression back. Notice it isn't resolved to coalesce 1, 0 as it is in SQL. We've just got the text of it back. So yeah, like I say, if you've got functions that you're using in SQL and PL/SQL, what are we going to do here? What's the best approach? You'll still need to think about it. And some of you might be going, well, is it really worth it? Is it worth taking our macros, our existing functions, I should say, and making the macros, or start taking our logic out of SQL and putting them into macros to make them more maintainable and reusable. So just to kind of demonstrate the kind of performance difference you get, let's use that total paid function I was looking at. We'll do it as a standard PL SQL function like this. So we just have the expression, and we'll also make it a Scalar macro. And I'm going to call it several times. So I've got my order items table with nearly 4,000 rows. I will iterate, basically loop through it 1,000 times, calling it for every row, to do about 4 million executions of these functions. And I've got it in PL SQL and as a macro. So I'll start that running because that will take a moment or so to execute. So as I say, essentially, I'm calling this 4 million times, the PL SQL version, and I'm calling the SQL macro version 4 million times as well. So we can compare the performance gains we get. And we look, the PL SQL took about nearly 12 seconds, or 11.5, 12 seconds. The macro took 1.5 seconds. So an order of magnitude faster. So the performance gains here, you know, if you've got a common expression that you want to use in your where clause, performance gains can be significant, and it is worth looking into, particularly if you've got this expression you're going to use many places. You know, something like, you know, calculating the total paid, you want to be pretty certain it's handled in the correct and standard way, right? Creating it as a macro is the way to go, right? So, but that said, as you know, there's still some thinking to do. You know, there's the classic thing that says, if you can do everything in a SQL statement, do it all in SQL. And we didn't have PL SQL. Now, with a macro, we can use that SQL macro. It is worth noting, if you've got some processing and you are not accessing table data at all, so you do not need to run any SQL statements, then PL SQL, pure PL SQL, is significantly faster than SQL. So if we just compare running the PL SQL version to the macro, they're not in a SQL statement. We're just crunching the data we've already got, for example. We can see PL SQL, pure PL SQL, is significantly faster. So again, we need to perhaps think a little bit how you're processing things and so on. Something like invoicing routines, quite often you'll collect all your data, do some pre-processing on it, and you have the information. You don't have to run multiple SQL statements. So got to think a little bit what you want to do there. All right then. We've got these macros, and as I said, with complicated ones, it can be a little unclear what's going on, particularly with complicated table macros. So I have my, I've kind of consolidated them all together. I've got my top end per group, passing different columns and so on to it. I've got a function for how many rows I'm going to get, and I've got my macro, Scalar macro in the where clause, which I'm passing some bind variables to. So what's actually going on here? What does a final SQL statement actually look like? So we can pass it to expand SQL text. And we get this, and the first thing you'll notice is there's actually quite a lot going on here, a bit more than just a straightforward find and replace. We've kind of wrapped it in layers of queries. So I say it's just a find and replace. It is a bit more advanced than that, okay? But if we scroll down, eventually, we will see there's the row number function that I called, passing in the product ID and the quantity. And again, you'll see it's fully resolved these from the identifiers I passed, like this, just lowercase, to be fully quoted names like this. And the function itself, the function name, so it didn't execute that function. If you remember, this just returned 5, didn't execute that and make 5 here. Function itself is part of the SQL statement. So we get the full underlying thing. Sadly, of course, as I said, with the Scalar macro, we don't actually see the underlying SQL expression. You just kind of got to know with this at this point, as far as I know. And we can see those are those bind variables. So this is this final SQL statement you actually get at the end. It's worth noting, if you're looking in like $SQL or do something else like that, you would still be looking for the macro call, right? You would still be looking for this SQL statement if you're doing any kind of performance analysis or things like that. You're not looking for this. You're looking for the actual statement that you submit to the database. So that So this can be really useful to help you debug and figure out what's actually going on with these. Finish off, got a bit of time to finish off. We'll just look at some examples. As I said, some common use cases which I've run into. So one is splitting this CSV into rows, and this is, it's a bit of a gnarly query. I mean, it's not too bad, but it's not obvious what's going on here. So we split that out into our 3 rows. We can create that as a split string macro, essentially pass that in as our template. And now you can tell all the developers just pass in split string like that. Awesome, fantastic. The really nice thing about this is it allows you to do something like a variable in list. You can't do in this, or you can do in that, but it's literally looking for this string, not all the individual values. If we want to have a variable in this and use it as a bind variable, we can now do something like this with a macro, and we can find all those. So this is potentially very, very useful. Worth noting as well, we could join to the result of the table macro. It is just a regular table from this point. So you can join to it, you can do all the other lovely operations that you would normally do to a table, and we can get those results there. Another thing, consecutive rows. I'm not going to go into the query too much, other than some of you at this point probably like, oh, what's going on here? But this is kind of the point. I've got a complicated functionality, and I want to make it reusable so we can find different things. So this is just finding how many people were hired on consecutive days. So non-obvious, we'll make it into a macro, and we can see we've got some logic in there to do all that. And now I can just call my get consecutive rows, which table and which column are we looking for consecutive values. Again, we could have a subquery. We want to find how many consecutive days there's been direct orders through the channel direct here, and we'll see we actually get 2 groups. It was like 1100, so what, 3 odd years worth of consecutive orders, then a gap, and then 260 odd. And again, we can pass anything we want to here. Final little example is a date generator. Again, the query to do this, it takes a bit of thinking about. We can create our macro to do it, and now we can do it to just generate some days, all the days in October. I've also passed in a parameter for the increment, so we could pass weeks. So I could pass a row for each week in 2021, that kind of thing. So much easier, much simpler. If you've got these common pieces of logic you want to use throughout your application, we can build these macros and make our SQL maintainable and easier to deal with. So to kind of wrap up, to recap, we've got SQL macros, and they are a SQL template, and there are 2 types of these: table macros, which you use in the from clause, and scalar macros, which you use basically everywhere else. Pretty much everywhere else you would use a PL SQL function. When resolving these, essentially what the database does is a find and replace. So the parameter names are placeholders in the string, and it takes text of those and replaces them. This is incredibly safe from Sql Injection, certainly compared to the alternatives. But it is worth noting this substitution only happens for table type parameters and other data types. If you've got a list of columns, you have to bind them, add those into the string yourself manually. Finally, this resolution happens at parse time. So it's a one-time operation when parsing. So that means at runtime, it's like, function doesn't exist. You've got pure SQL. So that means at runtime, there is no context switch. We've got the performance of pure SQL with the maintainability of PL SQL. So not only have we eliminated that context switch, the optimizer can help find better plans. Okay, like I say, not guaranteed, but in some cases it can make quite a big difference. So if you ever find yourself in a situation in the future where you've got some crazy complex SQL and you spent ages and it's like pages and pages long, and someone says, actually, that's really useful, we would like to be able to apply that to other tables, other columns, that kind of thing. Can you make that reusable? Well, the answer now is, oh, yes, we can with Sql Macros. So if you want to know a bit more about this, I've got some articles. If you want to check out 21C, this is available in one of the best ways. As I said, there's XE, but there's also our always free cloud tier. If you make sure you check the box for always free options, you can select 21C and use that there. Although, as I said, Autonomous is kind of its own version train anyway, so you can check that out. I talked a lot about this top end per group problem in this big blog post, but also how we can use it with SQL macros. And there's a live SQL tutorial showing you how to create parameterized views with these. So I can see there's a question. Could you share your script? Yeah, so I will upload it to live SQL at some point. So live SQL is still on 19C, not 21C yet. So those Scalar macros won't work there. When the Scalar macros work, I will upload it to live SQL and make that available there, so you can then test it out and try it out. So it will come. I just don't have it available at this moment, unfortunately. Any other last questions or comments before we wrap up? No. Everyone's like, well, brain exploded, trying to think about that and figure out what's going on, right?
Thank you, Chris, for the presentation. We have got still 5 minutes for the question and answers, and we would like to ask the audience if there is any question on the floor. Do we have a question?
Just say, they say, I have the, so if you go to the blog, blogs.oracle.com/SQL, most of my recent posts actually have SQL macros examples in them. So while the scripts aren't all kind of consolidated in one post, certainly those examples I was showing at the end, so CSV to rows, consecutive days, and things like that. If you search through that blog, you will find those examples somewhere. And this top end per groups talks about the problem and actually goes into, shows the macro as well. So check that out if you want to find some of the scripts.
Any questions? Let's track if there is any question. We've got still 4 minutes. Dear audience, dear participants, if you have any question to Chris.
Bruce has a question, I think.
Okay. Do you see there the question?
So is someone putting their hand up, or are they?
Or it is the buy symbol?
I'm not sure. Are they saying bye-bye? I try to.
He had a question about restriction controls.
Okay. Yeah, go on. So restrictions or controls, which okay, we're hanging in suspense while they type away, right? For example, we can put using only objects from user objects. So you mean if you're asking if we can access tables, yeah, it's tables that you've got access to. So that would be things from all objects, right? Not user objects. It would be things that well, I guess things in all objects you may not have query privileges on. But basically, so for columns, like I say, you can, so I guess there's a couple of things. Those views you would not use in the macro itself. If you writing queries inside the macro, you're going to have problems. Okay, as I said, that makes it non-deterministic. Second thing is you can actually pass in anything you want for a column as long as you don't actually use it in the SQL statement. Okay, so actually, if I go back to this one here. So for my consecutive rows solution, I am actually only using the first value. So I can pass in blah, blah, blah. Right, I can pass that in, and this is still actually going to execute it because I'm only referencing this first one. Obviously, if I do try and use this, which is just nonsense, it's not going to work because it's just nonsense. But because I haven't used its value in here, I can do that. However, if I try and pass in, let's just try and pass in blah here as the table, the whole thing's going to fail. It will just not even work in any circumstance. It won't even execute the macro. But the key thing here is with these columns, you can pass in junk. You could, and as long as you're not using it in your query, it will still run. Like I say, it's unusual you'll do this because usually you're going to go through all of these and use them in some way or another. But you might want to, I don't know, you can make these a debug flag or something like that, maybe, right? So it's a subtle point, but just something to be aware of, right? Okay, I think that's time now. So I think you know, I really hope everyone enjoyed this. More importantly, I hope you learned something. You know, it's great that we're organizing these virtual events, but hopefully we'll actually have some real events, physical events again sometime soon. So enjoy the rest of your day, folks, and we'll hope to see you soon.